Students, you are welcome once again to Prepclass Tutors. My name is Mr. Chima and I am your Prepclass tutor on chemistry. So today on chemistry, we are going to be looking at JAMB past questions for the year 2020. That's the one that was just previously written. So first and foremost, students, I want you all to try as much as possible to subscribe to our YouTube channel, and each time you watch our videos, try to click the like button. Hit our like button, you understand? Once you do so, you also see a comment section box. Please try and drop one or two things you find interesting about our video on our comment section box, because Prepclass will be very much interested in hearing from you. We need to know how our videos have been helping you. Do you understand how our videos have been helping you on not only chemistry but every other subject which you find engaging with Prepclass tutors? So today, Mr. Chima is going to be handling you on chemistry, past questions, JAMB to be precise, and today we are going to be looking at questions number 6 to 10. In our previous video, we looked at questions number 1 to 5. So today, very quickly, we are going to be looking at questions number 6 to 10. Alright, without wasting your time, let us move on. Question number 6. While the difference in electronegativity between bonded atoms increases, polarity of the bond does what? Why the difference in electronegativity between bonded atoms increases, polarity of the bond does what? Does it increase? Does it decrease? Does it remain unchanged? Does it reduce to 0? Now we need to know what electronegativity is. We need to know what polarity is. Now look at what I said here. Quickly, let me just use my point. I said here that electronegativity is the power of an atom of an element to attract electrons. The power of an atom of an element to attract electrons. You must know that atoms of an element can either be a metal, a non-metal, or a metalloid. You understand? Very good. Now, if an element is a metal, you know that it will have its electronegative value reduced, because metals do not have power to attract electrons. Rather, they can easily donate. Non-metals will have higher electronegative value because non-metals have power to attract electrons. Do you understand? So I said that non-metals have more electronegative values than metals. Why? Because they have the atoms have the ability to attract electrons to become what? Negative or charge. Now, polarity just simply tells us the difference in charges. When you have two atoms of two different elements, let's say sodium and chlorine, to form sodium chloride, there is a large difference in polarity. Why? Because sodium is highly electropositive and chlorine is highly electronegative. And also, there is a large difference in electronegativity, because sodium is what? Lower, has very low electronegative value, while chlorine has a higher electronegative value. Do you understand? Okay, so I said here now that in a compound like hydrogen chloride, chlorine will attract more electrons because it's a non-metal than hydrogen atom. Are you following? So since it has more electronegativity, therefore this would result in increase in polarity. So when there is a large increase in electronegativity between the two bonded atoms, for instance hydrogen and chlorine, whereby hydrogen is electropositive, chlorine is highly electronegative, there is a large difference in electronegativity, there will be a large difference or an increase in polarity. When we also have two compounds, let's say sodium and oxygen, sodium is highly electropositive, oxygen is highly electronegative. Are you following? So there's a large span or high mark of electronegativity. Sodium is highly electronegative. Oxygen is highly electronegative. Sodium has low electronegative value. There will be a large increase in polarity. Why? Because sodium will be highly electropositive in that sense, while what? Oxygen will be highly negative. So if there is a large increase, or if there is an increase in what? Electronegativity without bonded atoms, there will also be an increase in polarity. So the correct answer is what? Option A, increase in polarity. I believe you understand how I explained that. It's very simple. Question number 7. Elements P, Q, and R belongs to group 1. Elements P, Q, and R belongs to group 1, group 5, and group 6 respectively. They are telling you that element P, Q, and R belongs to group 1 of the periodic table, group 5 of the periodic table, and group 6 of the periodic table. Do you understand? So now, which of the following is true about the bond types of PQ and RQ? Which of the following is true between the bond types of PQ and RQ? P belongs to group 1. That means P is a metal. Q belongs to group 5. Q is a non-metal. Because metals are from, okay, let me even go to where I explained. Now look at here. I said elements in group 1 are highly reactive metals, e.g. sodium. Elements in group 5 are non-metals, e.g. nitrogen. Remember that in the periodic table, elements in group 1, 2, 3 are metals. Group 4 are semi-metals. Then group 5 to 7 are non-metals. Then group 0 are what? The red or noble gases. Are you following? That's group 0 or group 8. Now, elements in group 1 are highly reactive metals, e.g. sodium. Elements in group 5 are non-metals, e.g. nitrogen. Elements in group 6 are also non-metals too, e.g. oxygen. So now, metals combine electrovalently with non-metals, but non-metals combine covalently with each other. So because of that, since P is a metal and Q is a non-metal, so P and Q will combine what? Electrovalently. I believe you understand that now. And since Q is a non-metal and R too is a non-metal, Q and R will combine what? Covalently. So the answer is that P and Q electrovalently, because P will be donating electron, Q will be accepting electron, and Q and R covalently, because they may be sharing electron. Because they are both non-metals, no one will donate, rather they will prefer to what? Share. So the correct answer is B. PQ is electrovalent and QR is covalent. I believe you understand that. It's very simple. So let's move to question number 8. Question number 8. The diagram above will be used to determine the amount of. The diagram above will be used to determine the amount of. If you look at this diagram here, you see this place in this U2 below here. I have what? Anhydrous calcium chloride. Anhydrous means dry. Hydrated means wet. So we have a dry calcium chloride. You must know what calcium chloride is used for before you can answer this question. Now I have known volume of air. Air is entering in and air is going out of here. Air is entering in to enter into the calcium chloride and air is what? Going out of here. Alright. Now I say that anhydrous calcium chloride is used as a drying agent to remove water vapor from gaseous substances or substances generally. It absorbs water vapor. There's what we call a desiccator in a laboratory. If you want to prepare a substance to be void of water, we put it inside that glass container that is called a desiccator. That desiccator or glass container usually contains silica or fused or anhydrous calcium chloride. Silica and anhydrous calcium chloride are used to remove water vapor from substances. Are you following? So for you to put anhydrous calcium chloride here, it simply means that they want to remove water vapor from this air that is entering. Are you following? So I said that therefore the diagram above would be used to determine the amount of water vapor in air. Now for you to, they said known volume of air. Let's say 50 cm cube of air entered here. Then here, after it has absorbed some moisture, let's say 47 cm cube of air was gotten here. So for you to now, if you now say 50 cm cube that entered minus 47 cm cube that went out, it simply means that the amount of water vapor is now 3 cm cube. So that simply means that this experiment can be used to determine the amount of water vapor in air. So the answer is D, water in air. Why? Because anhydrous calcium chloride is used to remove water vapor from gaseous substances or any other substance. Very simple. Question number 9. The major effect of oil production in coastal water is coastal water. You must have heard of offshore, onshore. All these engineers that go offshore, in water drilling and drilling of crude oil and so on and so forth. Then I ask you, what's the major effect of what? They are asking you, what's the major of oil pollution in that kind of water, like the sea or ocean? Of course, it's crude oil spillage. It's crude oil spillage, because there's a tendency of the oil to spill, and when the oil does so, it will coats or cover the surface of the sea, thereby what? Suffocating the what? Fishes, and causing what? Toxicity in the water, which is a harm to what? Marine life. Birds and some other animals that feed on those fish will become what? Poison due to what? Oil or toxicity. Are you following? So if you look at the answer, which one is best? Increase in acidity? No. The distillation of the water. What's the meaning of distillation of water? Forget that. Destruction of marine life. Detoxification of water. Detoxification simply means removal of toxin. But the oil here actually contribute to toxin. Are you following? So the best choice here is destruction of marine life. But they choose increase in acidity of the water. That is wrong. The best choice is crude oil spillage causes destruction of marine life. Question number 10. Determine the pH of 2.50 times 10 raised to the power minus 5 molar solution of potassium hydroxide. Determine the pH of 2.50 times 10 raised to the power minus 5 molar solution of potassium hydroxide. Remember, I told you that this M here means moles per dm cube, which is also molar concentration. Now look at how we solve it. The first thing you have to do, they are asking you to find the pH. pH is defined as the negative logarithm of the what? Hydrogen ion concentration of the substance to the base of what? 10. Now, in potassium hydroxide, there is no hydrogen ion concentration there. You have to find it. So first of all, potassium hydroxide will have hydroxyl ion because it's a base. So write an equation in which the OH will dissociate to give what? Potassium ion and hydroxyl ion. There's a formula that says that what? Hydrogen ion times hydroxyl ion is equals to 10 raised to the power minus 14. See this formula here? Hydrogen ion times hydroxyl ion is equals to 10 raised to the power minus 14. That is what we use to find the hydrogen ion in the potassium hydroxide. After finding the hydrogen ion in the potassium hydroxide, we then find the pH, which is the negative logarithm of the hydrogen ion to the base of 10. I believe you understand me. So now dissociate this KOH, you have K plus OH minus. So OH minus, the hydroxyl ion, this is its concentration. Are you following? 2.5 times 10 to the power minus 5. Now I am looking for the hydrogen ion concentration. The hydrogen ion concentration is this one. I'm looking for hydrogen ion concentration. So using the formula hydrogen ion times hydroxyl ion equals 10 to the power. We drop this formula somewhere. So if you make the hydrogen ion the subject of formula here, that means you divide both sides of the equation by the hydroxyl ion OH. You have your H plus hydrogen ion equals 10 to the power minus 14 divided by what? OH minus. H plus equals 10 to the power minus 14 divided by OH minus. So your H plus now becomes 10 to the power minus 14 simply means 1 times 10 to the power minus 14 is same thing divided by hydroxyl ion concentration, which is 2.5 times 10 to the power minus 5. So bring it down, 2.5 times 10 to the power minus 5. So first of all, say 1 divided by 2.5. 1 divided by 2.5, H plus will give me 0.4. So 1 divided by 2.5 will give me 0.4. So now divide the indices part, which is 10 to the power minus 14 divided by 10 to the power minus 5. So 1 divided by 2.5, 0.4 times 10 to the power minus 14 divided by 10 to the power minus 5. So that's 10 to the power minus 14. This division in indices means what? Minus bracket. This minus 5 here, minus 5. So that's 0.4 times 10 to the power minus 14 minus bracket. Minus bracket means multiplication. Minus times minus plus. So you have 10 to the power of minus 14 plus 9 minus 14 plus, sorry, 10 to the power minus 14 plus 5 minus 14 plus 5 will give me minus 9. So that's 0.4 times 10 to the power of minus 9 mole per dm cube. So move the decimal point once to the front. This thing will increase by 1. So your hydrogen ion becomes 4 times 10 to the power minus 10 mole per dm cube. That's your hydrogen ion. concentration. 4 times 10 raised to the power minus 10 mole per dm cube. Now we now use it to look for the pH. So pH equals negative logarithm of the hydrogen ion concentration to the base of 10. So that's minus log hydrogen ion to the base of 10. So it's pure maths. So that equals minus log 10. What did we get as the hydrogen ion? We got 4 times 10 raised to the power minus 10. So you have to do it in a way that you can easily solve it. So that minus log 10 bracket 4 times 10 raised to the power minus 10. So that's minus log 10 bracket 4 times 10 raised to the power minus 10 equals minus log 10 4. This multiplication becomes plus log 10 raised to the power minus 10. So minus, if you use your 4-figure table, if you look at logarithm of 4, you get 0. Or your calculator, whichever one. Logarithm of 4 will give you 0.6021 plus log 10. Move this minus 10 to come here from logarithm. You have minus 10 log 10. So that's minus 0.6021 plus log 10 to the base of 10. Log 10 to the base of 10 from logarithm. Log a to the base of a is 1. So log 10 to the base of 10 is 1. 1 times minus 10 is what? Minus 10. So that gives you equals 0.6021 plus minus 10. So that becomes plus times minus here will give you minus. I'm supposed to remove this plus sign, sorry. Because plus times this minus is minus. I'm supposed to remove this plus sign, sorry for that. So we're supposed to have 0.6021 minus 10. And that will give you minus 9.3979. So these brackets here, minus bracket minus, that's minus times minus is plus. So you have 9.3979. 9.3979. So your pH becomes approximately, I think, to 1 decimal place. This 9 is up to 1. This 9 is up to 5 and above rather. So change it to 1 and add it to 3. That becomes 9.4. So your pH is 9.4. So you see how we got our pH as 9.4. We first of all use this equation to get the hydroxyl ion concentration. From there, we use our hydrogen ion times hydroxyl ion equals 10 to the power minus 10. Minus 14, rather 10 to the power minus 14. So remember, I told you to write this formula: hydrogen times hydroxyl 10 to the minus 14. Make hydrogen ion subject of formula 10 to the power minus 14 divided by OH. So this divided by this, we got 4 times 10 to the power minus 10 hydrogen ion. So pH negative log hydrogen minus log 4 blah 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 blah. So students, I believe you enjoyed this video and you've seen how we are destroying calculations here in Prepclass. So if you see below here, you see a link. This is a link. This link is a link to our WhatsApp group. So you can just copy and paste this link on your browser, or use this link rather to join us on our WhatsApp group. Use this link, copy this link to join us on our WhatsApp group. So when you join us on our WhatsApp group, you'll be having updates, you'll be having infos on the latest videos that we have available on our YouTube channels. So till we meet again, my name remains Mr. Chima, your tutor on chemistry. Bye and stay safe.